Okay, so today we're going over some logarithm problems, derivative of logarithms specifically, and I'm going to show you some tricks that make these a lot simpler than they really are. Okay, so for the first one we have y equals natural log of x over 3. So let's just go ahead and write this down, y equals ln of x over 3. Now when you're taking the derivative of a natural log, let me just rewrite this. When you're taking the derivative of a natural log, there's a nice little trick you can use, and you just take the inside of the natural log, which happens to be x over 3, and you write it down as a fraction under 1. So this would be 1 over x over 3. Okay, and then now we can take the derivative of the inside, which is derivative of x over 3 is just 1/3. 1/3, okay. And so to see what cancels, we can take the multiply by the reciprocal of this. 3 over 1, 3 over 1, and we notice that cancels out the 3. And so that leaves us with dy dx being equal to 1 over x. So this one's simplified into something very nice. These other ones will not. Okay, so now we have natural log of cosine of x. So dy dx. So we're going to use the chain rule to do this one because there's a function inside of a function. And last problem I told you that you just do inverse of whatever is inside of the natural log. And so in this case we have cosine over x. So we're going to start with a 1 over cosine over x. Now since it's chain rule, we do the derivative of cosine x. And we know the derivative of cosine x is negative sine x. And so now we have negative sine x over cosine x, and hopefully you know by now that sine over cosine is the same as tangent. So dy dx is equal to negative tangent x. And that's the answer for this one. Okay, last problem. This one is kind of tricky, kind of nasty. So we have sine squared natural log of x. So this actually looks really confusing, but it really is just a big chain rule problem. And that's really the hardest kind of natural log problem you'll see. Just a chain inside a chain inside a chain. And so I'm going to rewrite it in an easier notation. We put the sine squared all the way on the outside of the parentheses instead of having it in this notation here. This notation makes it a lot easier to see what you're supposed to do. Alright, so we'll just get started on the chain rule then. The first thing we would do is multiply our 2 and the exponent down, so then we'd have 2 sine of natural log of x, and then you subtract 1 from the exponent, and it becomes 1. So it actually ends up looking like a pretty clean answer here. If it was a different number, if it was like a 3, then it would be squared here. If we had a 1/2, then it would be a square root here. But anyway, we'll move on. And so now we need to take the derivative of the next function. So we did the squared, now we need to take the derivative of sine. The derivative of sine is cosine. Cosine, and then we just leave whatever is inside of sine. So I'm going to underline the 2, and that gave birth to this derivative, and then you underline sine, that gave birth to this derivative. It's kind of hopefully that's a helpful way to look at it. And now we're just left at the natural log. Derivative of natural log, the inside here, derivative of natural log is just 1 over x. And natural log here, natural log, that's the derivative is taken here. And so we have 3 things multiplied to each other. and then we can simplify it out. There's actually nothing to simplify. All we can do is write it nicer. So dy dx is equal to 2 sine, oops, mistake there, 2 sine natural log of x times cosine ln of x, and that's all over x. That's your final answer for this problem.